Hello everybody, it's me again. Today we're going to do an example that's in one of the technical blogs done by the Nvidia developer blog. So this technical blog is about 3 methods for speeding up AI model development with the TAO Toolkit. So this has 3 examples that you can do to fine-tuning pre-trained models with AI expertise, customizing pre-trained models for different use cases, and then this is adapting to different camera types, augmenting limited databases, adding new classes. And this is the example we're going to do today. And when I'm done, I will post a link to this blog, a link to the GitHub repo that is associated with this blog, and then to another GitHub repo where I've made some changes to the Jupyter notebook, because we're going to, once we're done with this example, we're going to export it and run it in Xavier NX. So Mr. Akihil Daka, we can thank him for this wonderful post. So let's get started. So this is the GitHub repo that is associated to that technical blog, and here it talks about the experiments that we're going to do. So we're going to do experiment number 3. We're going to add a new class of objects to an existing AI model. So the first thing we need to do is we need to clone the repository. So you run this and we'll clone the repository and put it on your machine. And that's what this is right here. I've cloned it. And this, you'll get this. And the next thing you do is we need a data set. So the data set we're going to get is a helmet data set from Kaggle. So you go here and download that. And where you place that at is once you download it, you go to this, data sets, helmet, and there should be a archive.zip. That's what you should have downloaded. And that you put that in there. And then once you do that, you go ahead and you got to make sure you've logged into you set up your NGC and your Docker login for your TAO Toolkit. And once you're ready with that, go ahead and run the Jupyter notebook. Start the Jupyter notebook by running this. So I've already got my Jupyter notebook running. So this is what you'll start out with. Process and run experiments on the helmet data set. So the first thing we'll do is, and there's more information on where to get the data set we're going to train on. So the first thing we're going to do is, I've run this before, so we're going to clear some results. So we've cleared out, this is a nice little feature, I like this. It clears out what we've done. I've already installed matplotlib, so we don't need to run this. Import the OS for processing this. And here, this is where we're going to set our paths for the Jupyter notebook and the container. So what I've done is, this was just set up to point at this, at the location of this Jupyter notebook. What I did is I went ahead and I replaced this with the actual path location. So you might want to do that. So then you run this. And then here's our files right here. So we want to unzip those. Let's run this. And it unzips it. And then the next thing we want to do is we want to, by the way, the images, this is the annotations. We don't want to use this. We need to put it in the kitty format. So the next one, I believe, will set that up. It's changed it to the kitty format. This is what we're going to need. And then we download the PeopleNet. We need to download the model we're going to use. And that will end up, let's see, let's download it. Models, the Technic, and the workspace. So here we are in the workspace. Models, the TechNet, and this is where it's downloading it to. By the way, I'm going to cut across a lot of the stuff. If it takes too long, we'll jump over it. But I'll show you like where it ended up. And so here's what we got. We downloaded this. There's the model. That's what we're going to use. Now we need to map our directories when we launch the TAO launcher. Oh, right there. And then I've run this, but I couldn't get this to work. But it doesn't seem to affect anything. It doesn't show. Generally, it shows like the mount where all the map to the directories. But I couldn't get it to do it. But it didn't seem to hurt anything. And then here is where we're going to set up our variables to interface the images with PeopleNet. So we run this. By the way, right here, experiments. These are your spec files right here. This is your training spec file right here. This is what it's going to use to be trained on. I'm sure you guys are used to this. You know. Into first people spec. In first news spec text. Okay, so we set variables to inference the images with PeopleNet, and then we also ran inference to helmet dataset images with PeopleNet. So we're combining the two datasets and labels that we have, and then this is where we're going to actually do the combination of the labels and existing labels with the existing helmet labels. And then now we want to generate the TF records because that's what we're going to use to run the TAO Toolkit on. And then now we actually generate the records. Okay, so we generated our TF records. If you go to helmet set all, right here, there are images. And our labels. And our TF records. So we're ready to go. So the next thing we need to do is we need to set our paths up for the ins and outputs of our training. And then here's where we actually run the training. So we get the training spec path, the train out, and the final model, and the TLT encode. So that's what we got going here. So like I say, what we'll do is it'll end up here. PeopleNet, experiments, and it'll end up here. Our output will end up there. So let's go ahead and start training. Now this is going to take a little bit, so I'll probably pause while this is training. So the training's done. Training's all done. So what we did is we got this train out, and these are the steps, and this is the weight it produced, a final weight. So there's our weight right there. So now what we're going to do is we're going to run this, and we're going to run some inference on some images and see what we got. So let's run this. I'm going to go ahead and pause it while it's running. So we've run inference on some images, and let's just go take a look at that. Trained out inference. So here's some of the images that it did. So it did a pretty good job. With helmets, without helmets, people without helmets. So let's go ahead and graph this. By the way, to get this graph to work, I had to repoint this to where the JSON file is. And the JSON file is located in here with the trained out. Down here. So to get this to work, you probably have to repoint that there. So this is our graph, and our images. So now that being said, I want to deploy this. We're going to deploy this to Xavier NX. Now to deploy it to Xavier NX, that's going to be another chore in itself. So that's the next thing we're going to do. Okay, so this is where the original Jupyter Notebook stops, is right here where the graph. So what I wanted to do is I wanted to export this out to Xavier NX so I can run it on there. So I've added this parts down here, and I'm going to go ahead and put a link to my GitHub repo that has the original Jupyter Notebook, but it has all these added components to it so you can export it out. So the first thing we can do is I took this from the TechNet Jupyter Notebook. So the first thing we can do is we just set up some paths. So we're in workspace, TAO experiments, to TechNet 2, TAO experiments, to TechNet 2, v2, and then to the data. So that's back here. That's where our images are going to be. And the other one, the path we're going to do is this is to the spec folder. So, but that is located here. CV samples, DetectNet, spec folder. That's where we're going to find this trained spec text. So I had to put that there. So the first thing we do is we do this. Connect our paths. Mount them. And then we double check them. So, and then this is where we convert our weights to the ETLT file. So what I did is I took the weights in the people net helmet experiments folder in the trained out. I grabbed this weight right there. And I went ahead and I put it in this TechNet retrain. So it's going to grab that and convert it into this model step 7700.etlt. Now I just picked that name because that's what the weights were assigned to. So it's going to generate experiment direct final and put that in there. Let's do that. So what it is, it went ahead and made the experiment directory final, and it loaded this in there. It created the ETLT file. Then down here we check it. It says it's in there. Now here we're going to take the training spec text and we're going to generate a calibration tensor. Now the specs directory from up here is set to where is it? Here, there, DetectNet, that's CV samples, spec folder. So I put it there because that's what it's set to, the path. So we'll take that and we'll make a tensor file. Oh, here's another thing too. In the specs file, let's look at this. It has all the stuff, workspace, TAO experiments, data, TF records, workspace, TAO experiments, data. So this is pointing to the, let's see, it's pointing to here. It's pointing to the data file in here and the TF records. The data, TF records, and I brought this over from the over here. Let's see. I brought the images and the labels and the TF records over from there and put them all in here because that's where it's set to. And another thing too is it's going to need the ResNet 34peoplenet.tlt, and I'm pointing it to what's over here. The let's see, TAO experiments, DetectNet v2. That's where it's being pointed to. So you got to make sure all that's correct or this won't run. So then we run this, and we're going to make a calibration tensor. If we go back to here, final, it's making a calibration tensor. So now this is where it's going to finally generate the int8 and the calibration bin and all the other things we're going to need for the export folder. So it's going to take the model step 700.elt, this. It's going to take the calibration bin, this. And it's going to do the final weights, which is... is that it? No. Right here. It's going to use that. And then it's going to use this final model, ETLT. It's going to generate that. And you set all this up, and it should generate all these things. So we'll just go ahead and see what we got. So it's done, and see it has a calibration bin, the tensor file, the ETLT file, and the int8 file. So this is all you need, except you need one where you'll need the text, the label file. So what we'll do is so this is what you need. So the only thing we have left to do is the label file, and we'll build that. We'll put that together once we get it over to Xavier NX. But that's pretty much it. Now, if you wanted to, you can use this down here, and this will actually generate the engine for you down here. But we're going to do this over on the Xavier NX. So anyway, so next time you see me, I'll be over on the Xavier. Okay. So what we've done is we brought the file, the experiment directory file that we've created over from the TAO Toolkit, and we're putting it in the models, TAO pre-trained models, PeopleNet. And then I put their experiment directory final. And this is the stuff we generated. And then we added this additional, I made this labels.txt file. And it has to be person with helmet, face without helmet. So you just got to add that. And then the other thing we did is what we're going to run is we're going to go to opt Nvidia Deepstream 6 samples, configs, TAO pre-trained models, and we're going to run, let's see which one, this one, Deepstream app source 1 PeopleNet text, and that's what this is over here. Now what I've done is, also in here is the other one we're going to use, config invert primary PeopleNet text. That's in here also. So the thing we're going to do is, this is the one, Deepstream app source 1 PeopleNet text. Pretty much left this all the same, didn't make any changes in here. The only changes I made is it's pointing at a video that I made, and it's of people with helmets and without helmets, so we're going to run that video in there. By the way, I had to make a video to went to the internet, gathered a bunch of pictures of people with helmets, and then just recorded them, so that's what we're going to use. Other than that, everything is the same. It's going to look for this engine, but since it won't have an engine, it's going to generate one. And it's going to look here, config invert primary PeopleNet text. That's where it's going to look at to need the information to build the engine. And I just left this default right here, 11 or config file, this tracker. Everything else is pretty much the same on this. And then what happens is it's going to call this config inference primary PeopleNet text. And this is where we got to point it at this. So we take the TLT model key, and the key is TLT underscore encode. The TLT encode model, so that's the final model.etlt. That's here. We're going to point it at this. And then the other one is labels.txt. We're going to point that right there. And then the model engine file. What happens is it's not going to have one, so when it makes the file, it's going to name it this. But you can change the name if you want it to have your name. And then here's the int8 calibration file, the calibration bin. That's there. So, and then the other thing you got to do is you got to change the classes. This was at 3, you got to change it to 4. And generally, that's all I did. Now, if you want to make it more sensitive or less sensitive, that's what all these numbers are for, and you have to play with those. But that's about it. So once you make that, all that, you got that in place, you made your label text, you modified this to point at this, then we're ready to go. So you bring up your terminal, got one going here. You see I've been running it. So you CD into TAO pre-trained models. You said DeepStream app, C DeepStream app source one peoplenet.txt, and then run it. Now I might jump over this because it's got to generate the engine, and you'll see over here when we're finally done, the engine will be generated and put in there. Now once the engine, so you see it's running inference on these, face, with helmet, person, face. So it's doing a pretty good job. So what we've done is we've taken the TAO Toolkit and we've taken PeopleNet and we've added another object in there to detect helmets, and then we retrained it. So now what it does is detecting helmets and people with helmets and without helmets and faces. So that's what it's all about, folks, from start to finish. All right. Thank you very much. Bye.